Hey guys, in this video today we're going to learn about a new kind of data structure, the linked list. And what I'm going to do in the future videos, or try to do, is the first part of the videos will be the conceptual explanation of what we're doing with our linked list. And then the last part of the video will be the implementation in C++. And so since we're just now introducing this, I expect that this video will probably run long. So this video will probably just be the conceptual stuff. And if you want to learn about the implementation, you'll want to go ahead and skip ahead to the next video. So with that, let's go ahead and get started. Now, I wanted to introduce a linked list by comparing it to a data structure that we already know, so we can kind of see the differences here. And so I've chosen an array. And if you remember, of course, you always have to declare the size of your array beforehand. And one of the reasons that is because the computer sets aside a block of memory of the appropriate size. And so each item in the array is directly adjacent to the previous and the next items in memory. And so it makes searching through this very easy, and I'll explain more about that in a second. Now with a linked list, each one of these little boxes here would be a node, and each node has some amount of information in it, and then it has a pointer to the next node. And that's how these items are linked in memory. They're not actually continuous in memory, they could be anywhere. And I've got them kind of in this neat arrangement, but again, they could be scattered out anywhere in your memory. And so you just have a pointer that tells you how to get to the next node. So some pros and cons. So pros in array, as I mentioned, if you want to access item number 500 in your array of strings, what an array does is it says, okay, well, start at the first location, and then it's an array of strings, so a string takes up so much memory, and then you want item number 500, so multiply the amount of memory that a string would take up times 500, and then that's going to get you to your 500, your item number 500 in your array, and you can do it basically in one step. And so it makes it where you can randomly access different variables or different things in your array very quickly in constant time. You don't have to iterate through it. It also makes it where it's easily searchable and sortable. So if you've got an array that's in alphabetical or numerical order, you can do a lot of different searching algorithms on it, and it works very efficiently. Some of the cons is that if you want to insert an item or remove an item from your array, it takes a lot of time. So if you've got an array of 1 million items and you want to delete or insert something in the second item, the second location, if you do that, you're going to have to either move everything down if in the case of deleting, and so the third item has to be moved to the second item, and the fourth item to the third, and so forth. And that's going to, you get 1 million items, it's going to take a very long time. Pros of the linked list is that insertion and deleting is actually very quick and easy, and we'll learn about that in the very near future, but it's very quick and very easy and only takes 1 or 2 steps. One of the other things is that the dynamic size. So anytime you have a linked list, if you want to add an item onto the end, it's no problem. You don't have to copy items over from the array into a new array of a larger size or do anything like that. You can just add it to the end of your linked list. Some of the cons is that you don't have that random access like you do with an array. So if you want to access the item number 500 in a list of linked list of 1,000 items, you actually have to start at the beginning and go through each item in the array. So that obviously would take quite a while. So let's go ahead and look at kind of what a linked list would look like. Here's your basic structure. Each one of these items you'll have a node, and these nodes are generally structs, and inside of that struct you'll have a pointer that points to your next node. And so up here at the top, I've got a singly linked list, and then below at the bottom, I've got a doubly linked list. So these nodes down here have pointers both to the previous node and to the next node. And so from this node, you can access the one before and the one after, whereas with a singly linked list, it's a one-way street. This node has no idea how to access the node before it. So you can only start at the head here and move to the tail, whereas with a doubly linked list, you can move both directions. Now, let's go ahead and talk about more about what's in a node itself. So the only thing required to be in a node on a singly linked list, you have to have a pointer to the next node. And for a doubly linked list, you need a pointer to the next node and a pointer to the previous node. And then you'll just have some amount of information that would, like a struct. And let's go ahead and maybe look at an example. So maybe let's say this node, this is a contact in your phone, right? And so you probably don't have all this information filled out for someone, but you might. And so you've got a first name for them, last name for them. You've stored their phone number as an integer, their address as a series of strings, their birthday, and then maybe you've got an array that says what contact groups they're in because you've got them organized, and maybe they're in a couple of contact groups. Maybe they're your friend, but you also work with them. So this array stores and tells you which contact groups they're in or something, and then maybe the date created or whatever. Again, this is arbitrary. I'm just making something up, but that you get the kind of the idea of what you might want to store in a node, and this can have. This could have structs inside of itself, so you could have a struct of structs or struct of with arrays inside or what have you, as long as you have the 2 pointers you need, which to the previous and to the next. And so I think that's it for the basic introduction on a linked list. And this is short right now, but I think if we start on the code, it's going to take a little bit. So I'm going to go ahead and end it here, and we'll pick up about the coding part in our next video.